So let's start with the first question. A child P weighing 30 kilogram force wears shoes with a heel of area of cross section 10 centimeter square, and another child Q weighing 20 kilogram force wears shoes with a heel of cross sectional area 2 centimeter square. Compare the pressure exerted on the ground by their heels. Okay, so we are having two children P and Q, and we have to find that what is the pressure exerted by these two childs on the ground by their heels. Let's start with child P. So we will note down the given data first. So it is provided in the question that child P is weighing 30 kilogram force. So we have to convert this kilogram force into Newton. So it is already known that 1 kilogram force is equals to 10 Newton. Therefore, 30 kilogram force will be is equals to 30 into 10. That is 300 Newton. Now let's talk about area. Area of cross section of one heel is 10 centimeter square. We have to convert this into meter square. Okay, so we know that 1 centimeter square is equals to 0.0001 meter square. So 10 centimeter square will be 0.0001 into 10. That is 0.001 meter square. Now, the tricky part is there is in this question, the area of one heel is given to be 10 centimeter square. But of course, a child will be wearing heels on both the foot, right? Both the feet will be having the heels. So we will multiply this value into 2. So that is 0.001 into 2, that is 0.002 meter square. That will be the value of area for both the heels. Now let's find out the pressure. So we know the formula for pressure. Pressure is equals to force by area. Force is 300. Area is 0.002. That's all this. If I will remove this point, there are 3 digits after the point. So we will add 3 zeros. Now let's solve this. So 2 ones are 2 and 150 is 300. So we will be getting the value 15 into, let's count the number of zeros, 1, 2, 3, 4. So 15 into 10 to the power 4. Similarly, we will solve the same thing for child Q. Okay, so child Q is also having force given in the question, that is 20 kilogram force. Let's convert this into Newton. So we know that 1 kilogram force is equals to 10 Newton. So 20 kilogram force will be is equals to 10 into 20, that is 200 Newton. And area of one heel is given to be 2 centimeter square. So first let's convert this into meter square. So 1 centimeter square is equals to 0.01 meter square. So 2 centimeter square is equals to 2 into 0.0001 meter square. That would be 0.002 meter square. Now we will we will multiply this by 2 because again there are 2 heels. So 2 into 0.0002, that is 0.0004 meter square is your area. Now let's find out pressure. Pressure is equals to force by area. So force over here is 200 divided by 0.0004. Let's remove the point. After that, we are having 4 digits. So we'll add 4 zeros. Okay. Now 4 ones are 4, 4 fives are 20 and a 0. So we will be getting 50 into 10 to the power 4. Okay. So we have got 2 pressure. Okay. Pressure for child P, let that be pressure 1, and then pressure for child Q, let that be pressure 2. So if we compare it, that is P1 by P2, we will be getting 15 into 10 to the power 4 divided by 50 into 10 to the power 4. Now 10 to the power 4, 10 to the power 4 will be cut. We will be left with 15 by 50. So let's divide it further. So 5 threes are 15, 5 tens are 50. So you will get the value 3:10. So that is your answer. Now let's move on to question number 2. Calculate the pressure due to water column of height 120 meter. And it is given that density of the water is 10 to the power 3 kilogram per meter cube and gravity is 10 meter per second square. So let's solve this. So we have to find out the pressure. So we'll simply put the values in the formula. We know that pressure is equals to height of the water into density of the water into gravity. Okay, so we are provided with all the data. Height is given 120 meter. Density is 10 to the power 3 and gravity is 10. So now we'll simply multiply it. Now we'll count the number of zeros. 1 plus 3, that is 4, plus 1, that is 5. So we can write 12 into 10 to the power 5, or we can also put a point over here. Since we are having one digit after the point, we'll add one more value over here. Okay, so 1.2 into 10 to the power 6, and it is pressure. So pressure का SI unit होता है Pascal. So pressure is equals to 1.2 10 to the power 6 Pascal.